Hey, what's up, everybody? I'm Nick. I'm the Chief Product and Tech Officer here at Arcadia. I've been here forever. I am going to talk a bit about the lakehouse, which is both a general concept. Lakehouse is a general data architecture concept that's kind of both meaningful and meaningless depending on how it's applied. And Arcadia has a very specific implementation of that technology that we'll talk like a little bit about here today. I don't have a ton of primer here. When we talk about like a lakehouse data architecture, show of hands, do we know like more or less what we're talking about here? Primer be useful? Some skepticism. The basic premise is to bring together the best attributes of a data lake, right? Which is really, really good for things like low cost of storage, easy ingress of heterogeneous data, fully distributed, horizontally scalable, really cheap compute. It's really good at all that stuff, but it's really bad at providing governance layers and the types of enterprise-grade data reliability like ACID guarantees in all of your transactions. And so the lakehouse sort of attempts to fuse these two concepts together and bring you the same level of velocity and price to performance of a data lake, but with the same type of governance and analytics-grade data layer that a data warehouse would provide. That's sort of the high-level concept. Cool? All right. This is just like a little bit of a brag reel on Arcadia. You're here. I don't know how many folks know who we are or whatever, but we're a healthcare data platform. We've been around for a while. We've been a largely servicing provider in health plans, so we do a fair amount of life sciences work as well. And our basic premise is that we, as a country, spent like a ton of money, about 10, 15 years ago, digitizing health records. And basically, we just lifted and shifted transactional systems into a digital experience and didn't really reinvent anything. And in those transactions, there's like a wealth of really, really valuable data that if you're able to tap at a massive scale, you can do all sorts of cool things like building and deploying AI models, providing analytics to power member engagement and population health activities and a whole bunch of other stuff. So that's kind of what we do. We work with a bunch of really awesome organizations. This is just a subset. I just see Tandem in the back, so I'm giving a pointer here. But we work with a bunch of great folks and have been doing it for a really long time. Within our cloud platform, we've got around 150 million patient records flushing through. We process something to the tune of like 20 petabytes of data a month, which is just like a gobsmacking amount of data to be flushing through our cloud. We're connected up with around 3,000 providers and payers. A bunch of other great stuff. And we've got a bunch of great capabilities, which if you show up, at the various booths, you can see all of our applications and our workflows on top of that. We talk about a health data platform. There's a few components of this. I'm going to start at a really high level, and then we can go slightly deeper. But ultimately, for all of our customers, we are really, really good at acquiring information. So the breadth of healthcare interactions over the past 5 years has really, really increased. It used to be that a lot of stuff happened within the four walls of one organization, but increasingly there's meaningful health encounters that are taking place at home, at urgent care, in the primary care and specialty setting, in a hospital setting, on mobile, et cetera. And so we're really good at acquiring all of that information, shoving it into a data lake, and running hundreds of analytics models at massive scale. And so I want to talk about those 20 petabytes of data. That's all being flushed through our analytics pipelines where we're doing things like treatment groupers and procedural groupers, quality measurement calculation, risk adjustment, all sorts of predictive ML models, all of these things to take one bit of data and enrich it to be a lot more valuable than the original bit. Ultimately, we stitch all that data back together that then powers all sorts of use cases, and we touch basically everyone in the healthcare continuum, whether it's a physician, care team extender, analyst, data scientist, etc. That's the health platform. Let's talk about the stack that it's built on. Now, this gets a little bit techy, but I can tell you about all the cool stuff that's running under the hood here. Our data gateway is how we acquire data into the system, and part of a lakehouse premise is shifting from a traditional ETL model where you're really, really focused on transforming data up front into an ELT model where it's just get the damn data into the lake so we can do something with it later. You know what I'm saying? And so our data gateway is very, very focused on, it's not a very intelligent gateway in some ways. It's all about just feeding data into the lake so we can use the power of cloud native compute to do all sorts of wild stuff with that data. We use Apache and NiFi. You'll see on this deck, we're a partner of AWS. They've got a fantastic health cloud and a bunch of some of the best price to performance that you'll get in any cloud vendor within their cloud, but we marry that with a number of open source technologies running on the Apache, largely the Apache Foundation, but a lot of great tech there. So we acquire data into our data lake. Within that data lake, we have the power of distributed compute. So any bit of data that lands in our lake, we run millions of lines of code in a streaming analytics pipeline on top, and that's largely Apache Kafka and Spark. One of the pieces that we bring to the table in the data lake is a medallion data structure. Anyone here familiar when I say a medallion data model? What that means? Cool. Love that. Thank you. What it means is different stages of maturity of a piece of data. Okay, so think about a document. We might get a PDF thrown over the wall. That PDF is data. We don't always think about a PDF as data. It's actually a series of bits that can be serialized and processed. So that's data, but it's not that usable. And so we apply a bunch of analytics models on top of that, including NLP and subsequent data extraction techniques to turn that more or less raw data into different stages of maturity. And so a medallion data model references bronze, silver, and gold, like medals that you win in an Olympic, where the bronze tier is really, really ugly data on the far end. Silver is more canonical data sets, and gold is what we would call analytics grade data. We manage all of that within our lakehouse platform, and we're able to run those millions of lines of code at incredible scale in that pipeline. Ultimately, we manifest the lake to our customers via warehouse. And when we talk about the lakehouse, it's effectively providing real-time visibility into the data lake with mature data modeling and governance that is applied at the warehouse layer. Last thing, I won't get too techy, but all of this information, and again, we've got like 150 million patient lives here, has to be manifested to end users. And we use all sorts of techniques to do that at crazy scale. So I don't know if you folks are familiar with SIL or Cassandra, but massive node data stores that can support hundreds of thousands of concurrent API requests without breaking a sweat, right? That's some crazy tech. We have been modernizing that platform over the past 12 months. Here's some interesting stats. These are largely internal stats, but what they mean for our customers is that we're able to operate more reliably at a lower cost basis for the massive amounts of data. And this data improves. We basically double the data footprint for our customers every year. So basically any customer we have, the amount of data we have for that customer increases 2x every 12 months. And so we have to do a lot to keep up with that. Over the past 12 months, we've had about a 50% increase in monthly active users. So our user base has increased 50%. Throughout that time, our application responsiveness has gone up 60% because of this cloud modernization. Query response time has gone down an order of magnitude. So basically, the question that you have to ask about your data is returned in about 10x the speed previously. And the stabilization of data coming through that pipeline has improved dramatically. And so when you think about running 2 million lines of code on every patient that comes through our platform, and every patient that comes through our platform amounts to petabytes of data every month, you need to be able to reliably process that in a compressed timetable, and that's exactly what this shows. Cool. Here's some real-world performance of this new data lakehouse that we've launched. And just to back up, when I talk about cloud modernization, it is effectively releasing this lakehouse to our entire customer base. Here's some real-world stats on what it takes to run a particular job or query. So a lot of prior processing jobs that used to take minutes can be can be returned in seconds. Really big analytics jobs. I don't know how much of you all have big data processing jobs within your organizations, but sometimes these things take hours or days, and we've been able to compress that down where we can run massive, therapeutic groupers and procedural groupers in minutes instead of like literally 20 hours. So it's a massive improvement in terms of our compute capabilities. Results speak for themselves. Is actually friend of the company, Julia Landry, who works for Umpqua, and her organization has experienced a pretty dramatic increase in their analytics responsiveness on the backs of this. I'm ripping through fast. So a couple of additional pieces of value on this platform architecture that are worth getting into. First of which is speed to market on new integrations. Really important if you're building this type of infrastructure is building what we call a software development kit or an SDK that applies on top of the lakehouse so that you're not reinventing the wheel every time you need to design a new compute. Okay? If it looks like a nail, it should apply a hammer to it. I'm misusing that metaphor, but you understand what I'm saying. You shouldn't have to be reinventing how you apply different computes. And so because of the fact that all of our customers' data is available in a single hub, that hub is available via really, really high scale storage and compute, we no longer have to reinvent how to apply certain analytics. And so we are compressing our roadmap where we're able to take an idea to launch in a couple of weeks instead of 6 to 12 months that would take previously when you're negotiating how to get data and where to return it to. The velocity of data to end users, I was just talking about that. We talk a lot about end-to-end data latency. So what's the distance between data landing and data being available for use from an analytics standpoint? That end-to-end latency we've compressed by an order of magnitude. The tiering of data is really important. This is that medallion data model. Oftentimes, organizations really negotiate and wrestle against themselves, trying to figure out, hey, there's this new piece of data, right? We want all of a sudden this genomic data, or we want this data. I think Brendan was talking about wastewater, right? That can be an indicative of early syndromic surveillance, right? How do we get that into our data ecosystem? And oftentimes organizations will wrestle themselves for months trying to figure out how to stage that data. What's the schema? And you lose time to value. And so with the medallion data model, you're able to acquire that data in basically days and make that available to end users, and think a little bit later about how to increase the fidelity and utility of that data. Last piece is observability. So the fact that part of the tenets of a good data lake is a zero-copy hub-spoke architecture, where the data lakehouse represents the sole source of analytic truth, and any copy is seen as ephemeral. And what that enables us to do is provide really, really clear data observability, so the quality of data that our customers experience is really, really high.